When we are discussing about problem background, currently in Sri Lanka, we can see the big problem in coconut cultivation. There are minor of coconut cultivation. Coconut owners has to pay high cost for the maintenance and the production. Lack of replanting, coconut pests. In addition, there are various types of diseases in coconut tree. Stem and branch diseases, leaf diseases, and pest diseases. Currently in Sri Lanka, there is a big threat from coconut pest and the coconut leaf diseases. Some leaf diseases are growing up by wind, so sometimes we have to cut those trees to protect other trees from the diseases. Normally 5 years taken for one coconut tree in Sri Lanka for growing. So after 5 years, owners have to cut these trees because of these diseases. That is a very big disadvantage. When these diseases are caused, coconut trees reduce their healthiness and growth. Production of coconut in Sri Lanka hampered by many diseases such as bud rot, stem bleeding, leaf blight, and Gandharva root and ball root, which occur in small patches in 2006. An unusual yellowing and flaccidity in leaflets of coconut palms in Veligam area in the Mathura district was observed. Hence the name Veligam coconut leaf wilt disease was given to the disease. So trying to control this situation is very valuable to save our coconut plantations. As a very first step, owners can identify the diseases by changing colors of coconut trees. When they are identified that they have contact Coconut Development Authority, and the second step is board member has to come and visit the land and have to recognize the disease. So there are a process and time wasting and money wasting for traveling here and there. When we are discussing about research gap with LR, there are several projects have been done to identify coconut pest. So far there are no projects has been done in Sri Lanka or other country to identify coconut leaf diseases. Especially the latest diseases in Sri Lanka, in Mathura Veligama coconut wilt disease, the trees are getting yellowing in this disease. Additionally, there are some image processing projects have been done for jute plant disease identification, coconut leaf disease, not cotton leaf disease identification, fungal disease identification system, and there is one project I have found for coconut stem diseases. When I am doing this research, I have found lots of details from literature review. These all projects are done in research level. They do not use image processing technology for this one. The main thing is there is no suitable dataset for do this project. So I have created my own dataset with capturing diseased coconut leaves. Coconut leaf diseases are mainly causes for lack of coconut cultivation in Sri Lanka. Currently people have pay high cost for coconut plantation for the fertilizer and the maintain things. If they are well maintained, sometimes trees got this disease. So owners have to cut or destroy these trees, or they can contact the Coconut Development Authority and contact their member. There are few members in this for support team. This research will help for the owners to identify the diseases. They can check daily their trees, no need to contact other person. This will be a very helpful for coconut growing in Sri Lanka. In old research papers, they have mainly mentioned coconut pest. About coconut leaf diseases, they are mentioned in small paragraph. This is the other reason I have chose this project. Additionally, in past research papers, we can't see the latest disease, coconut wild disease, because this disease is started in 2006. So after 2006 research papers, we can see this disease. There are no more good research in currently. According to the past research papers, we can choose a gap for image processing project. The overall scope to be covered in this concept map, the diagram divides the field into review, project domain, tools, existing systems, issues and technology. When we are going to the tools, the mainly using Python language, and when we are going to the existing systems, there are several existing systems. Those are mango plant disease identification system, coconut pest disease identification system, and jute plant identification system. Then when we are going to the issues, the main issue is the project, the lack of data set. In Coconut Development Authority also doesn't have a suitable data set for this project. So I have created my own data set. The other issue is lack of diseases information and the other one is the accuracy. I have to train the model a lot of times to get good accuracy. Then we are talking about the technology. We can divide into two things. This one is image processing and second one is machine learning. In machine learning there are two types of learning. The one is supervised learning and the other one is unsupervised learning. Supervised learning is a machine learning approach that's defined by its use of labeled dataset. These datasets are designed to train or supervise algorithm into classifying data or predicting outcomes accurately. And the unsupervised learning use machine learning algorithms to analyze the cluster enable datasets. And the supervised learning also we can divide it into two things. One is classification and the second one is regression. This is my project model code. I used Google Colab for build this. Firstly, in this section shows some important necessary packages and libraries. Then this section shows mount the Google Drive to Google Colab. In next section, assign some common values. These are the epochs are set as 47. The batch size is 32 and default image size is 256 and the path is set as image dataset Google Drive path. Size of images is equal 0 and learning rate is assigned to 3. Next section showing function to images convert to an array. OpenCV is used for it. Firstly, images are resized 256 256 and then return images to an array. Then function next function shows get images from directory. In here load images are in JPG image format. In this section can get size of processed images. In this section In this section, after loaded images, image dataset firstly labeled. Label binarizer has used for that. Fit transform is used for training data, so that we can scale the training data and also learn the scaling parameters of that data. The fit method is calculating the mean of variance of each of the features present in our input data. Then the model was used pickle dump function to store the object data to the file. This is label is pickle file name. WB means write binary and the disease label. File open or writing in binary mode. When writing in binary mode, Python makes more changes to data as written to the file. Firstly, print the label binarizer classes as healthy, brown spot, and leaf blight. In this section, list of image array convert into numpy array. Then this section, train test split function is used under the sklearn model for splitting data arrays into two subsets and as training and testing data. When this function used, don't need to divide the dataset by manually. By default, sklearn train test split will make random partitions for two subsets. In addition, xsize parameter decides the size of the data that has to be split as the test dataset. This is the given as a fraction. In here, the test size value is 0.3. The data set will be split 30% as the data set. Also, random state was used 42. Then this section, Keras sequential model selected as the model, because the sequential model API is a way of creating deep learning models where an instance of the sequential classes is created and model layers are created and added to it. The sequential model API greater developing deep learning most in the situations. In this model, there are three convolutional layers are included. Three layers consist of 3 by 3. Kernel size is 32 and 64 filters. ReLU is used as an activation function. Same padding was used and input shape were used 256 pixels. In RGB 3 channel. In addition, max pooling layer, batch normalization layer, dense and dropout layer were used in this model. Dropout layer was used for avoiding overfit. Softmax is open as the activation for the last layer of a classification network, because the result could be interrupted as the probability distribution. This is the summary of the model. In this model, Adam was selected as the optimizer method. In addition, binary cross-entropy was used to compile model as the loss function. In this model, fit function is used for train the model. Train, B-train, batch size, validation, data epochs, validation steps were passed as the argument under the module fit method. This is the code currently I have done. This is my current progress of the project, and trying to get high accuracy for the data set. And this is the front end I am hoping to develop. Now it is 50% completed. I am trying to do it my best when 28th of April in this year. Thank you.